Welcome students and good day. In today's class we will learn how to integrate this question, integral e raised to the power of cos x times cos of 2x positive sin x times dx. Now this quantity which you see is nothing but theta. So actually what they have given is, they have given us integral e raised to the power of cos x cos of some angle theta, but of course our theta is nothing but 2x positive sin x. So that is how you need to view this particular question. So don't be intimidated by seeing 2x positive sin x. That's all I want to tell you. So let me just take this integral first. Consider, this is the question, I'm giving you the solution here. Consider integral e raised to the power of cos x times cos of 2x positive sin x times dx. Now I would like to shed some light on the Euler's representation of a complex number. Now if z is a complex number of the form, say, x positive iy, then this particular complex number can always be represented as e raised to the power of some I theta, and this is, of course, we got r, the representation would be r times e I theta, and this is nothing but r times of cos theta positive I sin theta, where r is equal to root of x squared positive y squared and theta is equal to tan inverse of y over x. So this is the representation that I wish to bring to your information. Now it is also imperative to understand that this e power I theta is what we are going to be utilizing. Now this is actually the side note. We are not going to be exactly utilizing this, but any complex numbers representation is given in this fashion. That's all I want to tell you. But from this representation, all that I would be utilizing is e raised to the power of I theta. So clearly we see that e raised to the power of I theta is nothing but cos theta positive I times sin theta. Now if instead of theta, as I mentioned to you, you have to visualize theta to be as 2x positive sin x. So if I were to take that 2x positive, there is no I there, so it's only sin x, so it's even more simple now. So we got cos of 2x positive sin x positive I times, in place of theta I'm going to substitute 2x positive sin x. Now on the left hand side this is nothing but e raised to the power of, in place of theta it's going to be 2x positive sin x. Now we are only given this, we are not given this, so we need to eliminate this. So how am I to eliminate? Simple. When I am representing cos of 2x positive sin x, I will simply say I would be only considering the real part of e raised to the power of I of 2x positive sin x. That's all we need. So wherever I see cos of 2x positive sin x, I would be simply utilizing real part of e raised to the power of I times of 2x positive sin x. So I gave all this information just to utilize the all important representation for cos of 2x positive sin x. So let me continue with the problem. So therefore integral e raised to the power of cos x times cos of 2x positive sin x times dx is equal to integral e raised to the power of cos x times real part of e raised to the power of I times 2x positive sin x times dx. Now I can very well take this real part out, no harm in that, so I will replace it like this: real part of integral e raised to the power of cos x times, now you got I of 2x positive sin x. So let me distribute I. So this is going to be e raised to the power of I times 2x times e raised to the power of I times sine x times dx. Now this is rewritten as real part of integral e raised to the power of cos x. I'm going to bring e raised to the power of I sin x together. So this is e raised to the power of I times sin x times e raised to the power of I times 2x times dx. Now a raised to the power of m times a raised to the power of n is equal to a raised to the power of m positive n. So by this property I can join these two, and that would give me real part of integral e raised to the power of cos x positive I times sin x times e raised to the power of, I'm going to write this as 2 times I times x times dx, right? But what is cos theta positive I sin theta? It's e raised to the power I theta. I can also write cos x positive I times sin x as e raised to the power of I times x, right? So this is equal to real part of integral e raised to the power of, this entire thing is going to be e raised to the power of I times x times e raised to the power of 2 times I times x times dx. So foremost, I would like to make a small substitution. I would like to say let I times x be equal to, let me take it as some p. So there's going to be I times dx is equal to dp. So dx is equal to dp over I. So we will have to make some substitution over here. So this is going to be real part of integral e raised to the power of e raised to the power of p times e raised to the power of 2 times p times, in place of dx I'm going to be substituting dp over I. Now this can be further rewritten as real part of, I is a constant, so I'm going to write it in front of the integral, 1 over I integral e raised to the power of e raised to the power of p times e raised to the power of 2p. I'm going to write it as e raised to the power of p times e raised to the power of p, followed by dp and then the parenthesis. Now this is what I'm exactly doing. Now e raised to the power of 2p is going to be e raised to the power of p positive p. This is nothing but, if you have a raised to the power of m positive n, you can rewrite it as a raised to the power of m times a raised to the power of n. I'm going to apply the same concept. So this is going to be e raised to the power of p times e raised to the power of p. So that's exactly what I'm doing. Now I would like to club these two together. Now let us make the following substitution. Let e raised to the power of p be equal to some s. Differentiating, you would get e raised to the power of p times dp is equal to ds. So e raised to the power of p times dp would be replaced with ds. So this is equal to real part of 1 over I times integral e raised to the power of p is going to be s. For this e raised to the power of p, I'm going to place an s. For this e raised to the power of p times dp, I'm going to place ds. Okay. Now we can always use integration by parts. Using Liet concept, I would take u to be as s and dv is equal to e raised to the power of s times ds. Now I hope you know the formula. Integration by parts, uv negative integral v du. So this entire quantity is going to be equal to real part of 1 over I times, my du is ds, my v is integration of e raised to the power of s, that's going to be e raised to the power of s. So substituting the formula, uv is going to be s times e raised to the power of s, negative, my v is e raised to the power of s, and my du is ds. So we will have to integrate this. This is equal to real part of 1 over I times s times e raised to the power of s. When you integrate e raised to the power of s, you get e raised to the power of s. Now this can be further rewritten as real part of 1 over I. I want to take e raised to the power of s out. If I were to do that, this is going to be s negative 1 with the parenthesis being enclosed there. Now let me revert all the variables back. First, I'm going to substitute s for, I would say, in place of s, I would be substituting e raised to the power of p. So this is equal to real part of 1 over I. So this is E, in place of S it's going to be e raised to the power of P, times in place of S it's e raised to the power of P negative 1, right? So this is what you got. But my P, what is my P? My P is nothing but I times X. So substitute that also. So this is equal to real part of 1 over I times e raised to the power of e raised to the power of I times X times e raised to the power of I times X negative 1. Okay, but what is e raised to the power of ix? As I mentioned to you, this is nothing but cos x positive I times sin x. So if I were to utilize that, this is going to be real part of 1 over I times e raised to the power of cos x positive I times sin x times, this is cos x positive I times sin x negative 1. Okay, this is what we have got. Now I can always write a raised to the power of m positive n as a raised to the power of m times a raised to the power of m. Right, I can always do that. So this is equal to real part of 1 over I times e raised to the power of cos x times e raised to the power of I times sin x. Cos x can be clubbed with negative 1. So it's going to be cos x negative 1 positive I times sin x. Now I would like to represent cos x in the following fashion. Now there is a formula which is as follows: 1 negative cos 2x divided by 2 is equal to sin squared x. This can be further rewritten as 1 negative cos 2x is equal to 2 times sin squared x. Now if I were to take x is equal to x over 2 over here, then you get 1 negative. In place of x I'm substituting x over 2, so that would mean I will just have a cos x there, I mean just an x would be there, which is equal to 2 times sin squared of x over 2. So this is what I've got. I need to have a positive cos x, so that's what is occurring here. So for that you multiply by negative 1, and that would give me cos of x negative 1 is equal to negative 2 times sin squared of x over 2. So in place of cos x negative 1 I will be substituting this. So let me name this as 2. So moving on, there is also a formula for sin 2x. Sin 2x is equal to 2 times sin x cos x. Now if I were to take x is equal to x over 2, so this would become sin of x is equal to 2 times sin x over 2 times cos x over 2. So this is what we would get. So in place of sin I would be substituting this, but apparently, okay, that's fine. This is perfectly fine. We can just make the substitution. So therefore, all of these things are information. So this as all the required information for substitution. So I would like over here. Therefore, 2 can now be rewritten as this is equal to real part of 1 over I times e raised to the power of cos x times e raised to the power of I times sin x. In place of cos x negative 1, this is going to be negative 2 times sin squared x over 2. In place of sin x, it's going to be I is there, so just place that 2 times sin x over 2 times cos x over 2, right? And you can take this is real part of 1 over I times e raised to the power of cos x times e raised to the power of I times sin x. You can take 2 out, sin x over 2 out, and that would give us negative sin x over 2 and positive I. 2 is gone, sin x over 2 is gone. You get cos x over 2, right? This is what you have got. So this parenthesis is for this is also enclosed, and the outer parentheses are also enclosed with the flower parenthesis. Okay, fine, lot of parentheses. Anyway, now we need to push this I inside. Now if I were to move this I inside, what would happen? This would this I would be lost, right? This I would be lost, right? This I would get cancelled, and I'm only bothered Okay, let me just move this and then speak later. So I'm moving this. This is e raised to the power of cos x followed by a 2, and then this is real part. I'm only concerned with the real part, right? So I'm taking the 2 out, sin x over 2 out, e raised to the power of cos x I'm taking out. Now followed by e raised to the power of I sin x is there. Let me place that e raised to the power of I sin x there, and when I bring this I here, there will be negative 1 over I sin x over 2. I and I gets neutralized, giving me cos x over 2, right? So this is what I've got. Now I can perform some simplification over here if you wish, because let's do that simplification. Now I need to go to a new page, and this was the result that we ended in the last page. Now, as I mentioned to you, we have this negative 1 over I, but I would like to get rid of this. So I would be multiplying the numerator by I and dividing it by I. This is going to be negative I. I into I would give me I squared, but I squared is negative 1. So if you were to replace that, this is going to be negative I divided by negative 1, which is going to be positive I. So I can very well replace negative 1 over I as positive I. So this is equal to real part of 2 times e raised to the power of cos x. So let me write the 2 like that. E raised to the power of cos x times sin x over 2 times e raised to the power of I times sin x times, this is positive I, so I sin x over 2. So let me write that as cos x over 2 positive I sin x over 2. So this is what we have got. In fact, I need to place that parenthesis there. Now we know that, what do we know? Cos x positive I times sin x is e raised to the power of ix. So this would mean cos of x over 2 positive I times sin of x over 2 is e raised to the power of ix over 2. Do you agree with this? So this can be rewritten as, this is real part of, now 2 times of e raised to the power of cos x times sin x over 2 times e raised to the power of I times sin x times e raised to the power of I times x over 2. Right? Now I would like to club these two together. So this is going to be real part of 2 times e raised to the power of cos x times sin x over 2 times e raised to the power of I is taken out. So you get sin x positive x over 2. Right. Now as I mentioned to you, e raised to the power of ix is nothing but cos x positive I times sin x. So therefore e raised to the power of I times of sin x positive x over 2 is nothing but, in place of x I need to substitute this angle, this value. So this is going to be sin x positive x over 2 positive I times sin of sin x positive x over 2. Right? This is the angle. This is the angle. I need to place this in this fashion. So this is all just as a side note. So I'm going to take this value and place it there. So this is going to be real part excuse me, of 2 times e raised to the power of cos x times sin x over 2 times cos of sin x positive x over 2 positive I times sin of sin x positive x over 2. Right? Now we need the real part of this. So that is equal to 2 times e raised to the power of cos x times sin x over 2 times cos of sin x positive x over 2, positive arbitrary constancy excuse me, and that is the end of this particular problem. Thank you everybody, enjoy your night.